Hi, welcome to the Ashok Kumar channel Physics. This is the fourth video on electric current. Okay, so if you are finding any difficulty in electric current, then you can check the previous videos on electric current, which we have explained a clear concept about the electric current. How do the charges flow? So when an electric field is applied, and we have discussed about the drift velocity and on what factors resistance depends and on what factors resistivity depends, that we have discussed in the previous classes. So now we came with the new experiment which is very important. Here is Ohm's law. What is Ohm stated? Ohm is a scientist who has given a statement. The statement given by the Ohm's law is, suppose if you are having a resistance here which is connected to a battery, a cell. This cell is having a positive terminal and this is said to be the negative terminal. What is the direction of current? You need to say. The direction of current in the previous 3 classes, at least once I said the direction of current. In any video, the direction of current is always from higher potential to lower potential. Positive terminal is called higher potential and negative terminal is called lower potential. So here the direction of current is opposite to the direction of flow of electrons. Then electrons direction is from negative terminal to the positive terminal. There must be a potential difference, then only charges will flow. This is at higher potential, this is at a lower potential. There is a potential difference is created. That potential difference will drive the charges. Okay. Now the Ohm's law stated is, suppose if I am connecting a wire to the resistance R here, whatever the voltage source, that means potential difference is there, which is V, potential difference is denoted by the letter V. So if I am increasing this voltage, suppose if you connect 2 batteries, in case of 1 battery, what happens to this current? So current is nothing but the flow of charges. For V voltage, the flow of charges in a given time is, suppose if that is 2 amps. If I am increasing the voltage to 4, suppose if voltage is 2 volts, that means potential difference is 2 volts, then the current in this resistance is, suppose if it is 1 amp. Current units are amps and potential different units are volts. Suppose if I am increasing this voltage, that means the potential difference. How do you increase? By connecting another cell here. So if I have increased the voltage, that is 4 volts. So voltage increases means you are giving more energy. This cell is containing the energy, which is the chemical energy. So the energy provided by the cell is 2 volts here. So the 2 volts energy will cause a 1 amp of current. Then if you are increasing the potential difference means you are increasing the energy. If energy increases, then what happens to the current? So then charges will gain that energy, then those energy will pushes more number of charges in a given time. So if energy increases, then pushing force also increases, then more number of electrons or more number of charges will move in a given time. That means current also increases. The rate of flow of charges is nothing but current. Then more number of charges will flow if you have increased the energy. So that means then there is a 2 amps of current will flow. As I am increasing the energy, how you are increasing the energy? By increasing the potential difference. then more number of energy is available for the charges, then more number of charges will flow in a given time, that is said to be the current is also said to be increased. Suppose if I am increasing the potential difference to 8 volts, that means I am supplying more energy. By taking this much of energy, then more number of charges will flow. That means this current is also increases proportionately. So in order to equal them, this is 1 amp into 2 into 1 amp, and this is 2 into 2 amps, and this is 2 into 4 amps. See, this is a constant one. This is a constant one. This constant is called resistance of this material. This is about the Ohm's law. So this is said to be the potential difference, which is V, is proportionate to I. Actually, the current flowing in a given resistance increases with increase in the potential difference. So you cannot state in the reverse direction. Here current flowing in a given, current is nothing but charges flowing in a given circuit increases. When they are going to increases if you supply more energy. How do you supply energy? By putting a cell here, which is having a potential difference. Okay. So then this current is going to increase by increasing the potential difference. Current is going to increase by increasing the potential difference. You cannot state it in the reverse direction. Voltage, that means potential difference increases with increase in current. Can you say like this? No, this is wrong. Here current depends on potential difference. Potential difference is not depending upon the current. So the current increases with increase in the potential difference. That is the statement of Ohm's law. So the current which is flowing through a resistor is directly proportional to the potential difference supplied across its ends, provided the remaining conditions must be constant like pressure, temperature. These conditions are constant in the Ohm's law. They should not change. So you can write the statement of Ohm's law as this statement is very important. So many students are going to write this statement as wrong. So the wrong is they will write the potential difference is directly proportional to the current. This is wrong. Potential difference is not depending upon the current. Here the current depends on the potential difference. If I change the potential difference, then only current is going to change. Okay. So statement is current flowing in a given conductor, current flowing in a given conductor is directly proportional to the potential difference applied across its ends. So across its ends I am applying V volts, V potential difference. If I increase that potential difference, then current flowing through the resistance increases. So then you will get a constant here. V, this is said to be the potential difference is proportionate. As you are increasing from 2 to 4, current increases from 1 to 2. That means as potential difference increases, current also increases proportionately. Then if you remove this proportionate, then you are getting a constant here. This is a constant one. This constant is called resistance of this conductor. Resistance of the conductor. Then you can find out the resistance of given conductor R is equals to V by I. So this is how you are going to find out the resistance. Okay. Suppose we are doing this experiment for different potential difference. You need to show this statement with an experiment. So I need to increase the potential difference. If I increase the potential difference, current is also increasing. You need to show that one. So in order to show, first you need to do this experiment with one battery. So if you change this circuit with two batteries, two cells, then potential difference increases. So then the same circuit, I have increased the potential difference by connecting two cells in a series connection. So then this is having a potential difference V, this is also having a potential difference V. Then what is the potential difference? Becomes 2V. That means potential difference increases, this potential difference increases, then current also increases proportionately. Previously, then generally the cell is having about 1.5 volts. So suppose this is having 1.5 volts. If you are adding two cells, then it becomes 3 volts. Then find out how much is the current flowing in the circuit. How do you find out the current? So you need to add a ammeter here. Ammeter is an instrument which will show the current flowing in a circuit. So how much of current is flowing in a circuit, then you will get in ammeter. In the ammeter you will get the current. So by connecting 1.5 volts cell, what is the current in the ammeter? By connecting 3 volts of cell, what is the current in the ammeter? By connecting another cell, what happens to the resistance? What happens to the current? Current is also going to increase. As I am increasing the potential difference, current also increases. So then we will write those values in a table. So we are taking a potential difference here. At first I am taking a potential difference which is 1.5 volts. When a 1.5 volts of potential difference is applied, what is the reading in the ammeter which gives current? Write down this value. Suppose if it is 1 amp. When the voltage is increased from 1.5 to 3 volts, that is potential difference is increases. Then what is the current here? You can write the values. So as it is increased by 2 times, this also increases by 2 times. Proportionately it is going to increase. If voltage is increased to 4.5 volts, then measure the current in the ammeter. So now it is increased from 1.5 to 4.5, which is a 3 times increases. Then current also increases 3 times. Then you will get this is 3 amps. Then do V by I. Another table, another column, which is V by I. If you do V by I, 1.5 by 1, which is 1.5, and 3 by 2, this is also 1.5, and 4.5 by 3, that is also 1.5, and you will get a constant here. What is that constant? That constant is nothing but a resistance of the given material. Then you can find out this resistance by using this experiment. So here the experiment is not conducted at all conditions. While taking this experiment, the remaining conditions must be constant. That means temperature must be constant here. Already I said if temperature increases, what happens to the resistance? Resistance is going to increases. But here we are taking resistance is constant. In order to make that resistance constant, you need to take temperature as constant. You need to maintain the temperature constant when the experiment is completed, when the experiment is going. So this is about the Ohm's law. If you draw the graph between those values, between V and I, if you draw a graph by taking temperature as constant, by taking V on x-axis and I on y-axis. So V is changing from 0 to 1.5 and this is 3 and this one is 4.5 and current is changing from 0 to 1, 0 to 2 and 0 to 3. When voltage is 1.5, then current is also 1.5. Then when voltage, that means potential difference is 3 volts, current is 2 amps. When potential difference is 4.5 volts, then potential current is 3 amps. If you join these points, then you will get a straight line. In a Ohm's law, when you are conducting a Ohm's law at constant temperature, Ohm's law must be, you have to do at constant temperature. You have to maintain a constant temperature because resistance depends on the temperature. Here resistance we are taking as constant. In order to maintain constant resistance, you need to make the temperature constant. When you are making the temperature constant for metallic conductor, VI graph is a linear. Which type of graph this is? This is a linear graph. The relation between V and I is a linear relation. This is Ohm's law. So the conductors which are obeying the Ohm's law, they are said to be ohmic conductors. If they obey Ohm's law, the relation between potential difference and current, you will get this type of the graph. There are some other conductors are there like semiconductors, gases, conductors. They do not obey Ohm's law. Okay. So for those, you are not getting the same graph. So this is for ohmic conductors. What do you mean by the ohmic conductors? Which is very simple. The conductors which obey the Ohm's law are said to be ohmic conductors. Simple. For ohmic conductors, what is the graph of V and I? The graph of V and I is a straight line, which is a linear graph. For non-ohmic conductors, what is the graph? For non-ohmic conductors, so which conductors are said to be non-ohmic conductors? The conductors which does not obey the Ohm's law are said to be non-ohmic conductors. Sir, are there any conductors are there which are not obeying the Ohm's law? Yes, there are some of them. Semiconductors and gaseous conductors. Semiconductors are nothing but germanium, silicon. Okay. For non-ohmic conductors, the same graph. If you take the graph between V and I, you are not getting the same graph. Okay. As the voltage increases, at first the current is not going to increase, or you may get the different graph. You may get the graph like this. Even the voltage increases, at first current is not going to increase. After that, the current increases rapidly. This is about non-ohmic conductors. So, which does not obey the Ohm's law. Examples are semiconductors and gaseous conductors. So, Ohm's law limitations are there. What are the limitations of Ohm's law? First limitation is, in order to make the resistance constant, the temperature must be constant. It does not carry at all temperatures. The temperature, when you are starting the experiment, whatever the temperature is there, the same temperature should be maintained throughout the experiment, which is very difficult. Okay. And next, Ohm's law is not applicable for all type of conductors. It is applicable only for metallic conductors. And it is not applicable for the semiconductors and gaseous conductors. So these are the limitations of Ohm's law. Okay, this is about Ohm's law, which is very important in the public exams. So for 4 marks. So here the questions are how you need to write the Ohm's law experiment. While writing the Ohm's law, you must start with a statement. The statement must be perfect. The statement you need to write with current. Current flowing in a given conductor is directly proportional to the potential difference applied across it. If you increase that potential difference, current flowing through the conductor increases. So you need to show that one in the experiment. You need to increase the potential difference, then you have to see whether the current is going to increase or not, and you need to tabulate them and draw the graph between those voltage and current. Then you will get a linear graph, and for non-ohmic conductors you are getting a curved graph. And if you do this one V by I, then you will get a constant one. That constant is nothing but a resistance of a conductor, whatever the conductor we have taken. This is about the Ohm's law. Very simple experiment and very important experiment. Okay. And next, in the next class, we are going to discuss about if resistors are connected in series, what is the total resistance of the connected resistances. If they are connected in parallel, what is the total resistance? We are going to discuss about this one in the next classes. Okay, thank you, man.